So we've got an agenda of 2 speakers today. VJ is here to talk about our multi-layer maps functionality. And also we've got Joshua Bright here, and he's going to request some feedback and talk about some of the discussions we're having regarding joining Compute Federation. Hopefully he'll tell us all about that soon. And with that, does anyone have anything for the good of the order before we jump into these presentations? Do we need a stretch? Anything? Okay, well, I'm going to hand it over to VJ then, and we'll jump right into multi-layer maps.
Yeah, thanks, Nate. I hope you guys can hear me.
Loud and clear.
Awesome. You can see my slide screen, right?
Mm-hmm.
Okay.
Kind of a navy blue. It says OpenSearch Maps.
Yeah. Yeah. Thanks, Nate. Yeah. Hi, everyone. This is Vijay. I work at Amazon. My team is responsible for building the geospatial, KNN, and also neural search plugins. And today I am here to talk about give a demo about the OpenSearch Maps, which is released in 2.5. So let's look at the motivation for this project, for this feature. We all know that geospatial dataset can be viewed right now in region maps and then coordinate maps, but it has some limitations. For example, you can't add multiple index in the same map. You may need to hit a multiple region maps and add to a dashboard and then see it. But sometimes in geospatial use cases, you would like to see the data set, multiple data set within a same map, and probably you may want to see different data at a different zoom level. So those things are right now not possible with existing maps. So we wanted to address this concern, and that's why we released a new feature called Maps. That's going to be the de facto for any of the geospatial features in dashboard maps going forward. Next, let's look at some of the feature which we released in 2.5. So this is just a beginning of the maps application. In the future releases, you will be seeing a lot more features will be adding up to the existing set. So in this feature, we targeted adding multiple layers, and then you can display different layers based on different zoom levels. And also now you could also visualize your geospatial index as a multiple document layers. I will go to the demo. I'll show you how it is possible. And also not only that, you can also style your own layers rather than default settings. And you can also add some filtering to your index. That way you control of what data to see. And if you have more data, more layers, you can show, hide, and move within the panel. That way you could arrange your layer however you want. And also, sometimes if you want to see more data, you also have an option to view it. And at the end, if you are someone, you have a very specific use cases which involves different base maps, we also provide an option to include your own maps as a part of our maps. That way you could able to visualize it however you want. With that, I will go to the demo. Now, just quick check. You can see my screen with the playground right now?
Looks good to me.
Okay, awesome. Yeah, so now starting this, I have OpenSearch 2.5 installed in this cluster setup. And now you will see a new entry called Maps under OpenSearch plugins. So this will be the entry point for Maps going forward. So now, once you click on Maps, you will be taken to a landing page where you will see a list of previously created maps. Or if you are someone, you want to create a new map, you can also create it from here. So for this demo, I'm going to create a new map. Yeah, so once you click create new map, you will be you'll be provided with an empty base map. So this is powered by OpenSearch map service. And this is also something which is new we added recently. So in the region maps and coordinate maps, you have a raster tiles, but in maps, you will have vector tiles. So now you can see that zoom in and zoom out is much faster and smoother, and you don't have as latency as high as raster tiles. And on your left hand side, you will see an add layer. So you'll basically interact with the maps by building multiple layers. So I'm going to add a new layer from here. This in 2.5, like I said before, we added 3 layers. And if you look at the add layer panel, you have 2 types of layer. One is a data layer, other is a base layer. Data layer is where if you want to interact with an index pattern and you wanted to visualize the data, perform some analysis, you will be selecting a data layer. Or sometimes you may wanted to work with base maps. In that case, you will be choosing a base layer maps. So this is OpenSearch map is the one what we saw before, and custom map is the place where if you wanted to add your own map, refer to your own map from your own server. So I'm going to select one of the data layer, which is document. So this document layer will let me to visualize the documents from an index pattern on the maps. So for this demo, I'm going to choose a sample data flights. And this will now, once choose the data index pattern, now it will ask me to choose the geospatial field. So geospatial field here is basically either a geo point or geo shape. I'm going to choose destination location for now, and you can control number of documents you wanted to display. And let's say if you wanted, I know this is a GeoPoint data set, so I'm going to configure my points to styling something like this, and then I can increase my border thickness and then my marker size. And at last, let me give a name to it. Destination, and also here I can configure my layer corresponding to a zoom level. So what does it mean is that if you wanted your data to be selectively active in a certain zoom level, you can configure. For now, let me leave it to the default, and you also have an option to change opacity. This is quite helpful. Let's say if you have multiple layers share the same location and you want to see through it, the opacity will help you to see the layers, all the layers in a flat screen. So let me go and update it. Yeah, now you see I have a documents which is started rendering, but I only see a few documents. That's because I enabled only last 15 minutes. Let me change it to a bigger time window. Yeah, now you see data sets all appearing on my maps. So these are all individual documents from index pattern, which I could display it on the maps. And in the bottom also, you could see what's my zoom level and lat long location. That way you also get more information. Now what I can do is now I'm going to customize my layer by creating some filters. So let's say in the data flights, I wanted to only visualize a data set where my destination country is say from US. So I'm going to create a filter for this, and then let me update it. Yeah, now you see only the data set documents from the map from the US is only visible. Now let's say you wanted to know more information about the same document. Now we all know this is from US, but let's say I wanted to see some more information. In that case, I'm going to use my tooltip feature. So I'm going to enable it first and then say, you know what, I'm interested to see the destination city name, country, because we already know anyway, and then the weather. And then let me update it. Yeah, now you see that the information which were requested is now fetched from the server. Now you could see all those information as a tooltip on top of the existing geospatial point. You also see something called 1 of 13. So what does it mean is that there are 13 documents shares the same space in literally in the geopoint. So we cannot show as a tooltip. As one page, what we decided is if you wanted to see, you can just click, then it will take you to a paginated tooltip where now you could actually move along to see the different documents. And then once you're done with that, you can just close and then leave it. So that way now user could see the geospatial and also the non-geospatial data whenever they want on top of the maps. And also, sometimes you also may wanted to visualize the data only. I wanted to say for them. Sometimes you wanted to only visualize data whenever you see the map. Okay, this is really useful. Let's say you have a huge data set and then you don't want to load it. Let's say you are now visualizing a North America continent. You don't want to visualize, say, the Asia. Then if you enable that option, now the data from the other side won't be loaded. You only see data from what you see. And once you zoom out, then you start seeing the data. Let me show you. So right now we are only a part of the US. When this data is visible, then only when you based on the map region, you get the new data set loaded. This is going to improve the performance of the map rendering as well. And so not only that, we also have an option to visualize the shape. So let me select a new index pattern called USA_star, and I'm giving my geoshape field. Let me change my styles to a different, I think this should be fine. And then it doesn't matter. Let me remove the border. This will give a very good data set. And then let me name it as this and update. Yeah. Yeah. Now you see, you could also render a geoshape, and which is also geospatial field type on a map. So now you see that layer is built from bottom to top. You see our shape is on top of the point. If you want the point to come above the shape, you can use the drag handle to drag it down. Now you could reorder your layer based on what layer you want to see in the top. Again, this is all based on the use cases. We are also excited to see how customers are going to use it and users going to use it. Now, let's say temporarily you wanted to disable some layer. That way you wanted to focus on certain layer. You can select this hide button. Now that layer is now temporarily disabled. Now, if you want it back, you can just toggle it back. And let's say you can, this is also works for every layer independently. And at the end, let's say if you, and sometimes if you wanted to have, this is very useful if you wanted to have multiple layers shares same space. So this is for the geoshape. And let me also show you the settings of zoom level. So what I'm going to do is, let's say I'm going to keep my default map to default level and my geoshape to say visible only from 2, and then my flight destination to be visible, say starting 4. And then when you come out, you see now we are at zoom level 1.6. You see that only this layer is visible, and you see this layer is not visible outside of zoom level 2 to 22, and same for 4 to 22. So once you now zoom in, now you start seeing the layers start appearing. And then now let's go inside to 4. Now you start all the layers visible. So this is something which is not possible before. Now the user could able to add multiple indexes as a multiple layer, and then configure the zoom level to selectively activate and deactivate based on the use case. Yeah, this is what I wanted to demo for now. So this is just a beginning. For the future, we have planned to add a much more features, analysis, like aggregation, import your own data set, and draw filter, draw an object on the map to filter. So much more feature are on plan. I would recommend you to check out the dashboard-maps repository. That we make sure that we maintain the GitHub issue and then the relevant information for the community. Yeah, that's all for demo. Any questions? Yeah, I'm open to it.
Any questions for VJ? Awesome. Well, thanks for that.
Sorry, this is Ryan. Sorry, I have one question.
Awesome.
Okay, I think I just got it answered in the chat. I was asking if these are what appear as conventional visualization objects that can be using the conventional dashboards, and it seems like the answer is yes.
So, Timbanesh, I had a sort of follow-on question to Ryan's question. Given the new maps capability, and by the way, very cool, love what you've done here. What does this mean for the current coordinate and regional map visualizations themselves?
Yeah, It's a good question. So what we want in the future is to have one place where you could bring the coordinate map and then a region map as a layer. So whatever feature you could do in those two maps, you should be able to do it in the new map itself. So this is what we wanted to achieve, so that you have everything in one place. But till that moment, we are not going to remove, or we're not going to duplicate any of the existing features. That's something probably we will request the community. We will collect some feedback, and then we'll take a call. But going forward, the scope, the expectation, I mean, what we're thinking, you should be able to do whatever in those two maps inside this itself.
Cool. And yeah, as per Ryan's question, so we can then save this and still use these maps on the dashboard.
Yeah, good question again. So it's not yet available in 2.5. It is something which is going to come in 2.6 and 2.6. Right now, you could visualize as a separate object, but I think in the future, you will be able to have an option to here add to dashboard or include the maps as a new type in the dashboard itself, which is going to come. Yeah.
Great. Thanks. I appreciate it.
Thank you for the question.
Yeah, I can add a little more context as well. This is Josh Romero. I work on the dashboards team. Yeah, with a lot of these new experiences, the ultimate goal is to kind of converge so that one, any existing visualizations or saved objects you created, you can still leverage and use, but within kind of a new, nicer framework. So we're on the road to kind of convergence, and this is the first step. But yeah, eventually, we also kind of expect over time that as folks have access to this map functionality, they'll tend to move over there. But we'll make that transition as smooth as we can from region or coordinate map, or even people that are doing maps in Vega.
Awesome. Any other questions before we move on to let Mr. Bright have the floor here? Awesome. Well, VJ, I think what you guys have done is really cool. I haven't had a chance to play with it myself, but I think I'm inspired to go click on a few things. So I thank you for that.
Yeah, thanks, Nate.
Without further ado, I think I may as well hand it over to Josh here. Josh, are you ready to take the floor?
I think so. Is everyone able to hear me okay?
Loud and clear.
Awesome, perfect. So Nate had asked me, what is the Compute Federation? Is it like a group of like-minded people, or rallying around a common cause? In this case, this is more around being able to access data where it rests. So increasingly, we're hearing from the community that folks are tightening their belts and trimming costs where they can. So we're definitely hearing that on our side, and I think we have a couple of ideas as to how we can help not only increase the amount of time that people have access to their data, but be able to reach it in areas that are cost optimized from a disk perspective. So the core kind of problem that we see is people have data not only in OpenSearch. I think those that are here on this call can certainly relate to that, and it's challenging to get access to that data and visualize that data alongside your OpenSearch data. So we have thought of a concept of what we call Compute Federation, or other people call it SQL Federation, which would afford you the ability to reach the data where it exists. That data could be in Prometheus, that data could be on S3, it could be in a more generic kind of object store on, within Azure or Google Cloud. We want to help increase kind of transparency of the overall data where it exists, whether it be in OpenSearch or elsewhere, and bring that and make it available for you to access. And I think in the fullness of time, explore this idea of joining data across different data sources and utilizing the power of OpenSearch for dashboards and search to be able to harness that and run your analytics. So I'm joined here with Ani, who is going to go into some details about what we're thinking, and we would really love to get feedback in your thoughts. So, Ani?
Cool. Thanks, Josh. Let's go ahead from here. This is going to be more of a feedback session and less of a session where I'm giving an architecture and this is what we're doing. This is starting an idea and I'm going to portray a story and where it started. And I'd like to get everybody's feedback or works, solutions or use cases that they would like to apply it or ideas to change this. The goal and the work started really as we've getting a lot of use cases with how do we use S3 on OpenSearch, or how do we use raw S3 data, not just indices on S3, but use data in S3. The problem came from log analytics, where a lot of logs are stored in S3, but also BI spaces where a lot of data is actually stored in S3 first, and then the ETL runs to move it into different places. So the goal was, let's have OpenSearch do a secondary index and then run with S3 data where the small fields in S3 are indexed over here and work over that. We did a few POCs over this, and one common problem that came to light is the OpenSearch aggregation framework is a very simple MPP framework. It doesn't have multi-stage shuffles or the power that we really need at compute federation. So OpenSearch is a good indexing engine, a secondary index engine. It is not a good compute engine. The more we wanted to do this solution in OpenSearch, the more we realized researching into the topic, this is being done very nicely with Spark, Presto, Trino, and some of these use cases. So instead of rebuilding and reimagining everything, the goal was here to federate compute from OpenSearch into Spark. So we can take OpenSearch indices and use them in Spark. We can take Spark available S3 data, existing data frames, and any Spark jobs that you have created for your own businesses, also available over here. The initial integration point is going to be from a user standpoint. A user creates a materialized view or fires SQL queries that go into Spark. SQL into Spark is purely a data frame abstraction. So before the data frame is created, the user or the admin is able to create a data frame to however he wants his data to be laid out. Eventually, data frame creation is something that also we can simplify, but those are things that we are phasing out. In the initial experience, we connect Spark to an OpenSearch cluster using a remote connection. After the connection is established, we can do SQL federation, and SQL federation gets SQL queries in. There are certain work items over here that I'll go through one by one before I just open the floor for questions. The user-facing feature over here is materialized views or virtual indices. We can create a concept of a virtual table, and the virtual table is going to establish what part of a data frame is moved into OpenSearch. Hive Metastore or some other metastores can manage the query metadata. So the planners can eventually use smartly which indices to use for what queries and where to pull data from. The visualizations from the system can work over a virtual index or with a materialized view. So all existing visualizations, dashboard, discover, all tooling will work on this out of the box. S3 queries can be also used as a use cases in observability for log analytics. So all your logging data, tracing data can go at high throughput, and you can store all of those at low cost in S3, but use Spark jobs or materialized views with partial data from Spark, created only as metrics or Spark lines in OpenSearch in indices. The third PR is for streaming ingest. So streaming SQL or SQL-based ingestion from Spark into OpenSearch will be also part of this project, where we can have data frames which can be periodically updated with streaming Spark. And Spark streaming updates can go over streaming SQL or over OpenSearch ingest into the indices to maintain consistency between indexed is in OpenSearch and the Spark data frames. And as we have the metadata for the queries, we understand the data in the table in OpenSearch and the table layout in Spark. We can run automatic workload distribution. We are planning this workload distribution for a few observability use cases and few high-profile use cases in phase 1. But eventually, this should be a generic framework for automatic workload distribution between how secondary indices can be maintained for datasets in Spark for acceleration via OpenSearch and dashboarding in OpenSearch. The end goal of this project is to have OpenSearch dashboarding and OpenSearch users get analytics, dashboarding, and visualization use cases over Spark data without them having to know Spark. They can run SQL or DSL queries as the materialized views are created. That's it from me. We can just take more questions on here and go from there.
I'm a little embarrassed. I had to ask the actual question, what is Spark? And as soon as someone said Apache Spark, it's one of those words that once you hear it, it comes back to you. But yeah, so we are talking about Apache Spark.
Yes.
So it's Tim Banash again. So if I understood this correctly, a big part of this is the ability to create a single query across multiple data sources, which is very interesting. I mean, we've essentially done something very similar with the product that we're working on at Sakonis, where we created the same concept as in the observability plugin, more broadly than that, but it's used by the observability plugin, the creation of a separate data source.
Yes.
We're using that to query, using our own analytic query language to a high performant time series database. We had questions over the query performance of the current OpenSearch ability and whether that was really the right layer to put a federated query in. So how are you thinking about the index structure? Because that in itself has inherent limitations in terms of its design for a federated type approach.
Can you repeat the last part of the question?
So the nature of the indexes and things, they do a great job on unstructured data and things, but more structured data, they're probably not the most performant way of creating that federated view. I'm just wondering how you were thinking about merging the result sets.
So the performance comes into question only for metrics use cases.
Yeah,
and metrics use cases are more columnar and get leveraged with compaction performance gains that Prometheus and other metrics and time series databases do. When we're talking about query federation doesn't really create a view or a index store. We don't copy data. Most of query federation is just federating the query, leaving it to the remote engine and using caching and distributed capabilities of the remote engine without replicating any of it. Compute federation is a bit different. Compute federation is not meant for primarily metrics. Compute federation is meant for any and all forms of data, including logs, which are textual in nature. Most of them are unstructured and they are not metrics. For those use cases, the performance is on par. The goal is over here having a single viewpoint from dashboarding and a simplified workflow to get data from OpenSearch and different data sources, including some of the ML libraries that you can use in Scala on Spark together as a use case.
Cool. No, thank you. My use case is primarily metrics. So
okay, yeah, that makes sense. In that regard, we could connect offline, I guess, because metrics is today not a good use case in OpenSearch, but there are some data structures and improvements that we can make in OpenSearch to make it better. There are some RFCs open on that. We can talk offline on those. But
yeah,
today,
no,
metrics is not a strong, solid use case in OpenSearch based on data structures.
we'd love to talk to you about that.
Thanks.
We had a hand raised. Sam,
Hey,
go ahead.
hey, Annie. So I think just to reiterate, if I understand correctly, right, like the problem at hand is really the user is trying to query the remote data and from various data sources. Not all of them are already kind of structured, right, like a snapshot or a Lucene index. I guess immediate question I have is like it sounds like do we choose, so I guess it's the two questions. The first question is, do we choose Spark because there is you also see there is a demand specifically for like a Spark interface or Spark RDD, or is it just because we kind of see it as a good example for a execution engine, for query execution?
I think I'll answer the first question first before we go.
Okay. Okay.
The problem, as you stated, is actually not accurate.
Okay.
Query federation is not a problem. Going into Spark doesn't automatically give us ability to federate into everything. We still have to write code logic to manage all the query federation. That's a subjective choice. We can do it in the SQL engine in OpenSearch much nicely. Depending on where we want to go. Some may be different with respect to use case implementations. Some remote connections are better in OpenSearch, some are better in Presto. It depends on how much effort you put into it, but that's not the goal. The goal for Spark is compute federation. Compute is something that OpenSearch is bad at. And when we do compute at OpenSearch nodes, aggregations at OpenSearch is a single pass. We can't do shuffles or multi-stage aggregations. And the MPP framework, if you really think about it, bringing in MPP framework or building an MPP framework, it's a lot of work and effort. And we don't want to redo that. So we want to use S3 with its maximum capabilities, but to use S3, we need aggregations. Now, if we do S3 based aggregations on OpenSearch, we basically end up killing OpenSearch. And we need the aggregations and power of Spark to run shuffles and compute at a cluster level. And that is where Spark is the most popular option. To be honest, the best option over here is also Flink. Flink does streaming really well. Flink has a lot of good abilities. The code base is really nice. But the community and a lot of the support that we have seen is behind Spark. So we might contribute Spark streaming into the project. And we've been also thinking about how to get SQL abstractions in Spark for Spark streaming. Spark streaming today does not have SQL, but Flink has. But SQL is a good user interface. So that's a subjective choice, what we want as a user interface and who is our user. Is the Scala writer or a developer our user, or is the dashboards user using a language a user?
So when you talk about federation of compute, like there are mechanisms in OpenSearch, right, that were introduced, like for example, the concept of ML node. So we can, or weights, or all kind of sharding and allocation mechanisms. Why do we think these are not sufficient or not extendable enough so that we can use those for the compute federation?
They're not that powerful if you compare them to Spark, and they're not that pluggable if you compare them to Spark.
Right. I mean, I understand the MPP and the execution engine. I understand that logic is not there, but I'm just kind of wondering whether, because it sounds like when you say compute, do you mean like to separate like the load so that we are not going to like involve like say an offline load with an online load of queries, for example? Is that?
No. So by that, what I mean is if you want to run an aggregation, What is the best way to divide a complex aggregation problem with evaluations into a 30-node cluster? How to run the results in multiple passes while you're returning the result set, collecting the top end documents and returning a good response while canceling some which are not required. All of that, those pieces of distributed aggregation execution that requires a lot of work, which has been done in Spark and is more popular in Spark.
Right.
But more importantly, we're not using this as a feature hidden. We want developers to have full access to Spark. So for example, if you're writing security threat use cases or security threat detection functions, you could write your custom code or custom functions in Scala and leverage the developer community at large in Spark to now generate these data sets and also move it into OpenSearch.
Got it. So maybe I can follow on the second question. It's kind of a little bit related to the first one. So I guess the second question is really about like how do you, like, one of the things that I think the project did really well, right, is that it was keeping the core more or less consistent and kind of clean. So I mean, kind of, right, like people will have different opinions about that, but more or less very, very, kind of tight. So I guess the question I'm kind of thinking is more about the operational and maintainability aspects.
Yeah.
Because now basically, how is it going to run? You're going to need to have like a separate deployment. Are we going to integrate this with the
Very
core?
good question. Yeah, very good question. So I think we're thinking in phases and long term over here. The first phase is at a logical tier with query and ingestion and workload execution. And for that, that's why we call this compute federation as phase one. And compute federation is you bring your own Spark. Whether the Spark comes from EMR, the metastore comes from Hive or some other metastore internal to us, it doesn't matter. It's going to be a remote connection and we'll leverage the administrative capabilities of the team or the service hosting Spark. We can bring in Spark for anywhere over here. But the real things become more and more powerful to OpenSearch as a whole when we get Spark and OpenSearch co-located together, single process, single node. A lot of those discussions are also very open-ended and just starting to happen. We don't know which way we are going there yet. And how to leverage this as part of the DSL. Because currently SQL does most of the interfacing with Spark, and the ingestion from streaming SQL goes into an index. So DSL can work off of the index, but direct DSL query execution on Spark, that's also a question to be answered, how to best handle that.
Oh, thank you.
Thanks, Aaron.
Looks like there's a question lingering in chat.
Cool. Which I don't have a chat queue over here. Or do you mind just?
Oh, sure, I gotcha.
Thanks.
So Aaron Den Gate is asking, just curious, how does the use case for federated compute compare to searchable snapshots? And then he also offers a link to issue 2919.
Got it. So federated snapshots are really Lucene indices, or more correctly said, Elasticsearch indices on S3. And you can search in those indices as if you're searching a hot node, and that is an OpenSearch feature. The Spark integration will allow you to just query and interface with a data frame. So you can do anything in a data frame, and you can write Scala code to get anything and everything you need into a data frame. So this is much more open-ended and not just limited to Lucene indices. Does that answer your question, Aaron?
Sure, thank you.
I think another way of thinking about it is, what does your SLA need to be, right? So if you need to have a relatively, quick access, then a snapshot that's already indexed, in a Lucene format, it's going to be much quicker, right? If you want to grab something that's off of S3, right, it's going to be a little bit slower. So I think, you can think about it like, how are you going to want to access that data, and what kind of SLA are you going to want around it? So maybe if you had some compliance logs that exist but don't, require somebody to be able to pull them up within a couple seconds, then maybe having that on S3 and not in Lucene format is reasonable. If you wanted to just kind of like extend the view of OpenSearch and just want to cost optimize storage, then searchable snapshots would be a good idea. Those are some examples.
So I'm curious, before we close this down for some
So I had a closing comment before we go.
Oh,
in.
sure.
There are no questions. So my closing comment is, please comment on the issues. I didn't want to start with keywords, but this is our way for OpenSearch to get into lakehouse use cases. The connections are not going to be limited to any particular provider. This is just going at Spark. So Spark running anywhere can be accessed with this. Now, Spark also has access to OpenSearch indices, term vectors, and a lot of internal details of OpenSearch. So if you want to run some NLP use cases, some search and relevancy use cases, you have full access to low-level data structures from OpenSearch or the Spark Hadoop connectors. So what do you have today after this use case or while this use case? You have SQL into Spark. You have Spark submit to custom submit jobs into Spark under the hood. You get OpenSearch data structures into Spark. And now we're looking for like use cases to correctly use these things together to solve powerful problems. Thanks, folks. Over to you.
Awesome. So you'll have to humor me here for a second. So Apache Spark, and I'm having trouble forming in my brain the notion of just pointing it at random data on an S3 bucket, for instance. Like if it were an S3 or a OpenSearch snapshot, for sure it knows how to interact with that data and parse it. But are you saying Apache Spark just knows files well enough to be able to say, oh, this is a particular type of file, I know how to return this?
No, very good question. So the way we bias everything is, one of the concepts of Apache Spark to hold data is a data frame. So when we connect to Spark, we're actually connecting to a data frame. And the way to create a data frame is by creating a streaming query, which creates a live updating data frame, or by creating a data frame, which is one time, but that is done by the admin user. So there is going to be somebody who understands their own S3 data and their own Spark to initiate this data frame. Now we can automate this for known use cases like security lakes or other observability solutions where the data is structured, there are schematized data sets. Those we will automate out of the box. But for by and large general data, we'll need an admin to define a data frame, and we connect into the data frame.
Gotcha. Okay, that was the piece I was
in
missing.
later
Thank you.
phases, when more and more use cases come to the left of the diagram, where OpenSearch can orchestrate data frame and orchestrate some jobs, then it will be more and more automated from a UI. But for now, it's a play between the admin of the Spark cluster and OpenSearch. But very
Awesome.
good. Thanks.
Okay, well, this has been some good conversation in here. Does anyone else have anything they need to talk about? David, Chris, David, did you need to talk about the upcoming 2.5 release or the recent 2.5 release?
Yeah, I can talk about it a little bit.
Yeah, if you want to, feel free to share your screen with your slide if you like, or just.
Yeah. 1 second, let me pull it up. So you all saw we did have the 2.5 release. It was a little bit later than we were hoping for, but that is okay. Better late than never, right? And better right than wrong. Let me pull, where did that go? There we go. Also, has anyone already started and downloaded the 2.5 release or testing it? That's phenomenal.
That's me. Awesome.
I know. That's good. Anyone else? Just drop it in the chat. I will share. Sorry, everyone. I'm on a new laptop and it is not quite there yet. There we go. So yeah, bunch of stuff that was released in the 2.5 release. If you haven't seen it yet, we have some new user face stuff for working with indexes and administrative operations on that. Oh, I also like you should pull up my chat on the side. Oh, nice. Glad to see people are testing 2.5. It's awesome. Yeah, go to my cookies and disable ad blockers. It's a good point. Yeah, we have Jaeger trace data that's now available with OpenSearch dashboards. And there was a Jaeger community meeting a couple of days ago. I'm not sure if that was recorded or not, but hopefully so. So you could go back and take a look at that. Maps and visualizations from multiple data sources. We saw a little bit of the work to come on that as well today. Yeah, Debian was released. We have artifacts for the new release. We don't backport those artifacts, but 1.3.8, I believe, is also going to get Debian. So I know a lot of people were waiting for that, myself included. It's nice to just be able to apt install OpenSearch. So we have some more threats added to security analytics, search rollup indexes, and the list goes on. I mean, there was a lot released. So definitely make sure you can check out the release notes, which I'm going to drop that link. No, I'm not. Okay, I'm going to attempt to drop that link in the chat. But if you don't know where to go, you can also ping either me or Nate offline and we'll happily send that to you. So thank you all.
Fantastic.
Just occurred to me, it's Amitai from Logso. If Ani is still on the call. So there's a lot of work being done regarding security recently, and I'm wondering if we have these data frames. I mean, those are accessible. Like, how is the security plugin going to be somehow intertwined with this?
Awesome. Very good
notion
question.
of
That is exactly the thing that we are fighting over here for the last 2-3 weeks now. So a couple of layers. OpenSearch itself has RBAC. Then we are connecting OpenSearch into something else. And the connecting into OpenSearch, we use credential stores, and those are key store or security manager or adapters to security manager. Or adapters to key store. And these are open source and AWS concepts. Other adapters can be added over here. So there are different layers at which we can unwind this problem. The first thing is a user connecting into OpenSearch. Then OpenSearch connecting into a remote cluster. And then there is authorization in data. Spark itself doesn't have anything by default, but you could use Ranger. And at what level do you want to authorize data in Spark via OpenSearch? And should OpenSearch care about it, or should we mandate Ranger on Spark clusters for this to happen? There are a lot of open questions on this. Currently, the only thing OpenSearch security mandates is the OpenSearch data in the OpenSearch index. So anything that you're writing from Spark as materialized views will be governed by OpenSearch policies. Connections out of Spark will be managed by their own RBAC and their own credentials. And data in Spark will be managed by its own credentials. We are looking for use cases if you want more than this, and how you would like to structure this or give some use cases over there. But this is a complex security problem more than an implementation problem at the base level.
I see. Another thing that crossed my mind while I was watching this presentation, which was very insightful, by the way. So one of the interesting things is that just kind of pops to mind is that you could possibly monitor Spark using OpenSearch.
Yep.
During doing it exactly like and use Spark at the same time, right? Using just the one single pane of glass.
Yes, I think in the next couple of weeks we'll have one more session on simple schema. Simple schema for observability or simple schema in OpenSearch are the concepts of schematizing a lot of log metrics and trace data, where we can start understanding default monitoring endpoints and do one-click monitoring on some of these things. Monitoring Spark is something definitely we haven't thought about before, but yes, you could do that. And you could eventually also run complex alerting rules or triggering rules for security policies in Spark.
Because the tools that I've seen data scientists use, I forgot the name of the last one I saw. It was pretty impressive. But the neat thing they do is if there's some error, then they see the error and they can go from there directly to the place in the notebook. And so if this kind of thing would keep what data scientists I've seen love about tools that they love is that they keep them in that one tool. They don't have to jump around from the Jupyter notebook to other places. They could either run everything from the notebook, or they can run it from some other, they run the notebook from via some other tool, but they don't leave that.
Yep. I think the goal for us is to keep everything as an experience in dashboards. We want to slowly use Spark as a compute resource, but keep the user with a lot of functionality in dashboards as a user experience.
I see.
But I think also on that note, there are plenty of ML tools that exist outside of the OpenSearch experience. And so, if there's an ability for us to have a great pipeline of real-time analytics data that would be accessible by those tools without having to duplicate said data, that's also a big win.
And also something you said, Joshua, is that in terms of cost. So this will, if you're coming from an observability standpoint, doing your data science, you can potentially have more observability on cost.
Yeah.
Whereas using a lot of the machine learning tools, they don't have, that's not top of mind in a lot of them.
The most important thing that comes to mind as a blocker with developers is every developer who's using any observability solution will tell you they have to limit how many logs just send to an observability solution. And nobody likes that. Everybody just keeps on filtering logs. But to really have correct use cases for observability, we don't want to limit that. And the limiting of logs comes from indexing, processing, and ingesting all the data. But if you don't have to ingest and if data is at rest, we can have data skipping jobs keep on running on S3 data to analyze and see which data sets need to be brought to a hot store. So the Spark use case is completely bypass ingestion, completely bypass everything.
Interesting.
Cool. Well, I did want to bring up that we are at time. Feel free to stop the recording if you like. I did want to leave you with a piece of advice. Feel free to stick around after we're done, but just remember that time flies like an arrow, but fruit flies like a banana. And with that, we'll get back to our regularly scheduled programming.